What is axial stress? I have already told you, means force acting in a horizontal direction, in one direction, particular direction, that is called axial. It may be transverse direction, means x and y. Suppose this is the direction of x. So this is the direction of y. So you consider any direction. This is axial. This is also an axial. So this is axial. This is transverse motion. Okay. So axial means in that direction we consider the force. Now that direction force applied on this direction means this is the x direction and this is the y direction. Okay. Consider this is the y and this is the x direction. Okay. This is the axis of the bar. Simple meaning. This is the axis. You can take this axis also. Also this axis. There is no confusion. Also you can take this axis. Okay. Suppose this axis consider. So this axis are parallel. You can consider from here, from here, from here, from here. This it's your choice. Okay. But according to your needs. So here we using the section plane means cutting plane. So suppose cutting plane is the plane that cut the body. Okay. So here cutting plane basically we pass out on that body means perpendicular this body. Suppose this is the body has two dimension. Okay. We passing the cutting plane in that direction. Suppose you see uh, you obtain the cutting plane. Cutting planes I have already told you. This is the 1 mm gap, 6. 1 mm gap, 6. Means this is the 6 mm length, 1 mm gap length. Okay. With 1 mm length, then 1 mm gap and 6 mm. Okay. So 6 1 6 1 1 6 means suppose 6, 1 mm gap, 1 mm length, gap. Okay. This is the gap, 1 mm length, then gap, 1 mm length. Means this is the 6 mm length, 1 mm gap, 1 mm length, 1 mm gap, then 6 mm. This is a chain line. If we consider these ends are dark, if these ends are dark, that is the section plane, cutting plane. Chain line, section line are same line, but ends are dark, then it is called section plane. So this is the cutting plane, section plane. Okay. Uh, Suppose this horizontal body, this is the vertical plane, and the cut. Okay, this is the cut. After cutting, we obtain this body. After cutting, we obtain this body and this body. Two parts here. First one part, after cutting, second part. So first one part this and second one part this. Okay, this is the suppose one part and two part. This is the here one and two. Okay, just we visualize the stress representation on that case. So suppose we have cutting the body. So after cutting, stresses are generated horizontally and vertically. Suppose parallel to this line. After these stresses are generated, this is the body basically 3D body. So some stresses are here. Okay, this is the stresses, and some stresses on lower portion. Okay, these are also applied. So these are here applied stresses means sigma. Okay, these are sigma, sigma, sigma. Okay, we consider only here one type of stress here. And second case we will consider an next example. In second portion, stress is also in outward direction. These are the outward direction. Okay, because this the component here basically is the here see this force acting actually here is stretching force. This is the stretching force. Okay, stretching force. So this is the basically stretching force. So component is stretched out. So after stretch out, so this suppose this is stretched in that direction. So balance should be compulsory. I have this force and this force balance out. So now suppose this force and this force balance out. Okay. So a direction should be this and this opposite, and this should be opposite. I think you are getting my point. So resisting force development, how to develop the resisting forces. So this is the basically here the representation of the uh, stresses on that component. So we solve after in some example. So now resisting forces acting on the section are shown in the figure here. This point B and A. Then now since the stresses are uniform, these are uniform, sigma, 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 or suppose here force consider R. R is the resisting force. You can consider sigma into area. This is the resisting forces. P is equal to sigma A. So P, because force are stretches, so P is equal to sigma into area. But here you want to calculate sigma. Sigma is equal to this force P upon this area. This force P upon this area. So force upon area, it is called here basically the stress. Okay, clear. So now here you consider suppose one strip, and after integrating the whole body, we obtain the R is equal to sigma dA. Sigma is throughout constant. It's just the constant because there is sigma, sigma, sigma throughout constant. So you taken out the outside the sigma of P, integral dA. So after integrating from 0 to A, suppose we have length has 0 and to A area. So 0 to A, we obtain the P into area, means sigma into area. Here, consider P is the normal stresses. So A is the cross-sectional area. Now, so in that cases, the consider the equilibrium of the cut piece of the bar. So here, for equilibrium condition, I have already told you P is equal to sigma, P is equal to R, and R is equal to sigma into area. Or you, according to this book, P into area. Basically, P is confusion term. P is denoted by pressure or normal pressure. But here we consider only sigma, not a pressure, because this is the pressure quantity. So you confused. So here use only the sigma into A. Okay. Sigma is the stress. P is the pressure in your mindset, and also in my our mindset. P is the pressure, but this book consider P is the sigma, P is the stress. Okay, so don't confuse, please. It should be clear. Confusion should be clear. So here sigma is equal to load upon area. I have already explained here. This is the load upon area. Okay. Now it depends upon the if we consider in especially if true stress, if the word is mentioned in the book or your example or in your note or in your question or in your theory question, true stress, then you should define sigma T is equal to force upon instantaneous area. Okay. Otherwise, you should assume sigma basically is the engineering stress or the conventional stress or simple stress. Okay. Now, so here he defined basically. I have already explained you, but in case of in that case, in the case of axial load P, stress developed is equal to load upon area, load per unit area. He is not mentioned instantaneous area or original area. So if true stress, then upon incidence area. So here it should be mentioned load upon original area regarding the stress. So you people, you should write engineering stress or conventional stress or simple stress load upon original cross-sectional area. Okay, this is the definition of the stress. Last time we have discussed under this type of normal stresses, bar is being extended because this is tensile forces, bar is extended to such stresses which is causing extension. Extension means permanent displacement, permanent distortion. Extension of the bar is called tensile stress. Okay, if bar is plastically deformed, then it is called extension, permanent extension. But extension or just deformation, it may be temporary or permanent deformation. If load applied on the body after removal of the forces of in the body, then it is disappear. That is called elastic body. If it is not disappear, that is called plastic body. So it depends on the condition given in the problem.